Thanks, Vinay. Hey, everybody. I'm Dinesh Joshi. I will be talking to you all about Apache Cassandra Analytics. Basically, it's a recipe to move petabytes of data and also talk a little bit about security at the same time. I'm an engineering manager at Apple, and I'm also on the Cassandra PMC. Been with the project for about 7 years now. So presumably everybody knows what Cassandra is, but really quickly, I just want to revise what Cassandra is. It's an open source distributed NoSQL wide column, highly available, linearly scalable database. That's a mouthful, um, but that's what Cassandra is. And as a result, we use it to store petabytes of data in Cassandra. It's one of the largest databases that you can use. Now, when it comes to moving data, like at this large scale, there are a bunch of problems that you tend to run into. So one of the things I want to do is for the room is to set up the problem statement. How many here have seen this type of an architecture in the past? By a show of hands. Okay, a decent number. If you have been in the Cassandra community, this is what is recommended as a architecture when you want to do something like serve live requests at the same time, also do some sort of analytical workloads. You create two data centers. One is dedicated for analytics. Can somebody tell me what is wrong with this picture? Okay. Yeah, I mean those are issues, but fundamentally this is an expensive architecture to be in, right? Let's not worry about DR here, but what we really want is basically we want why can't Cassandra serve both OLTP and OLAP traffic from the same data center, right? That's what it boils down to. So when you throw Apache Spark at Cassandra, you might have like 1,000 core Spark cluster, and you might have 100 node Cassandra cluster. And it's easy to kill Cassandra with 1,000 node, like just do a denial of service attack, and that's not something that we like to do. So, but this is the desirable architecture. Primarily, cut your costs down by half. So how do we get to this? Or what prevents us from getting to this, right? So the first problem that we want to tackle here is basically we want to analyze data in the Cassandra cluster in place. So we don't want to move the data around as if it's not needed, because at large scale, it's a very expensive operation. The second thing that we want to do is bulk load a lot of data into Cassandra, because Cassandra is a serving store as well, right? So you want to take data out of Cassandra into Spark. Sorry? I think it's okay. So yeah, you want to load data into Cassandra as well, not just like move data out of Cassandra. So you want to analyze data, but a lot of times you get a lot of data in S3, HDFS, wherever it is, and then move that data into Cassandra after you do your ETL processing for serving as well. So you want to have a bi-directional source and sink. And then while doing that, you don't want to bring your cluster down, right? That would be really bad for your users. So those are the three problem statements I want to leave you guys with. And but what makes this hard, right? Like why is reading a lot of data a problem? This is supposed to be a very scalable database, and it is for the purposes of services OLTP traffic. But what happens in OLTP or OLAP workloads is, I'm just going to give you the TLDR. The read path of Cassandra at a very large scale becomes expensive. So there's a lot of stuff that goes on when we want to read data out of Cassandra. This is by no means exhaustive list of things Cassandra does, but when it receives a query, there's a lot of stuff that it has to do in terms of reading data out of Cassandra or of the SSTables. Similarly, on the right side, it has to do a bunch of things as well. So when it comes to writing billions of rows or reading billions of rows, those costs tend to add up a lot, and that makes things slow. And if you were to look at how this manifests itself is If you look inside a Cassandra node, there is, networking cost, there is serialization, deserialization, there's some processing, there are Bloom filters, mem tables. You have to look up indexes and do a bunch of things on the Cassandra node. So now imagine, like, a lot of clients, they try to read data out of Cassandra. This has to happen a number of times, right? Whether it happens through the Spark job or through Java driver, it is still expensive. So how do we solve this, right? How do we make this better? So going back to the problem, right? What if we were to eliminate most of this cost and only leave you with some like very tiny amount of cost to pay on the node, on the Cassandra node, and move it off of the node to Spark? And that's what we ended up doing. It is basically it's cutting out. Okay, it's going off. All right. So what's the analytics, Cassandra Analytics ecosystem, right? It has two components to it. So one is the sidecar, and the other is the analytics library. The sidecar is essentially a process that you deploy alongside your Cassandra daemon. There are a few services that it exposes. I'll go over those in a bit. But the Cassandra Analytics library, essentially you need to remember is that the read and write path of Cassandra is basically extracted into this library and put in there. So in theory, what you can do is using the analytics library, you can actually materialize the data that is on disk of your Cassandra node using this library without actually involving Cassandra nodes in the process. The sidecar exposes a bunch of APIs which are useful. One of them being the token metadata. Basically, it gives you the topology of the cluster, and then snapshotting the data across different nodes in the cluster. It also allows you to stream those files that make up the data files of the database out of the cluster. So now I hope most of you can get imagine what I'm getting at here, right? So the top part is how the normal read and write path is still going to work. The bottom part is how the analytics library works. And what it does is essentially it uses the Cassandra sidecar, which is deployed alongside the Cassandra node as a side channel to retrieve SSTables or push SSTables onto the host that is running the Cassandra daemon. And as a consequence, the only cost that you're paying really here is just the cost of the network to stream the SSTables in and out of the host. And as a consequence of that, you can imagine like all of the cost of deserializing that data and creating a view is actually moved. Yes. Okay. I don't know what's happening with those mics. All right. Okay, I'll try to go faster. Okay. All right. So essentially, you're moving the costs from the Cassandra node into the Spark node because now all of the deserialization creation of the view that you are using to query against the data is actually moving to the Spark node. So now imagine if you could throw 1,000 cores at the problem. Now, earlier you could only throw 100 cores at the problem. Now you're throwing 1,000 cores at the problem. That's essentially what it is. We have benchmarked this to be about 30 times faster than what you can do. But this is, again, for analytical workloads, not the regular reads and writes that you're doing with Cassandra. Let's deep dive a little bit into the architecture of what is happening. I described a bunch of things. So this is part of the CP28 that was accepted in the community, and it describes the overall architecture of how the system works. And here, if you see on the right hand side, you have the Cassandra cluster, and on the left hand side you have Spark. Essentially, when the driver starts up, which is the Spark driver, it starts up. You want to read a bunch of data. You basically configure a few things, and the driver starts up. It retrieves topology of the cluster and figures out, okay, I need to throw maybe 5 tasks at the problem or 100 tasks, depending on the amount of data that you are going to pull out. And once that happens, then the individual tasks, they actually are reading data which is in a subset of the cluster. And what they do is they are connected to the Cassandra database itself, and also the disk is shared. So they have direct access to the disk that Cassandra is on, right? And what we do is we pull out the SS tables into the task, and then the task basically materializes the data. Again, like we use the same Cassandra read, Cassandra code that's packaged in Cassandra all jar. And this code allows us to pull data from multiple replicas, dedupe the data, and create a view of the data in as a data frame on Spark. And in doing so, this is exactly what you would do if you were using the Java driver. But what we are doing is we are moving all that computation over to Spark instead of having it inside Cassandra itself. Similarly, the write path is very, very interesting. It is also the same exact path, but except it's reversed. In this case, what we do is we actually generate, like, your data source is a data frame, and that data frame is what we use as an input, and we then take that data frame and generate SS tables. Those SS tables are compatible with the version of Cassandra that you're running in your cluster. Even if you're running on mixed mode, typically Cassandra can read its one major version older SS tables as well. So what we do is we generate those SS tables. Once they are generated, we validate that they can be actually read and are not corrupted. Because bit rot and bit flips are a thing. And then we push them into the sidecar. The sidecar then stages them onto the disk. And once they are staged, they load the SS tables into the serving view that Cassandra has using node tool import. And that way you completely skip the actual read and write path when you're like bulk ingesting the data into Spark or bulk exporting data into Cassandra itself. So depending on which direction you're going, you're basically just zero copy streaming those SS tables between the nodes. And that's pretty much it, how the architecture works. One of the things that I wanted to touch upon, which is coming, is like this direct connectivity between Cassandra nodes and the Spark nodes are great. But what happens when you want to actually restore the same data on a number of clusters? Then you don't want Spark to reach out to each of the cluster and write the data. So one of the things that we can also do with the analytics library is on the write path, we can actually write it to S3 or an object store that is compatible with S3 APIs. And by doing that, you could then take that data, stage it up to S3, and then ask the sidecars to restore the data onto the clusters. And this is a feature that is work in progress. Part of it has been already open source. Part of it is in the process of being open sourced. But this allows you to decouple the Spark writes from the restores on the Cassandra itself. All right, on to the next topic quickly about security. And how many of you here know about mutual TLS by show of hands? Oh, that's quite a bit. So for those of you who are not familiar with mutual TLS, I have a few slides that will be helpful. So what is mutual TLS? So TLS is transport layer security. It is certificate-based authentication. This basically means that possessing a certificate instead of a password is a way of authenticating to Cassandra. It builds on top of the TLS protocol. It's part actually of the TLS spec itself. And what you do is the client actually possesses a client certificate that it produces and shows it to the server, and server says, oh, I know you because somebody has digitally signed your certificate. And as a consequence of doing this, you basically eliminate passwords, right? So you don't have to deal with passwords anymore. And as you can imagine, this is more secure than just plain old passwords. So how does this all work? So this is the exchange that typically you have between a client and server when they need to, connect over TLS. And this involves the client certificate exchange as well. So in this case, the server and client will exchange their certificates, and the client will send its client certificate. Typically, you don't send a client certificate because you only verify the server's identity. But since we are sending the client certificate, that's why it's called mutual TLS, that you're mutually authenticating each other using your own certificate. In Cassandra, what we introduced is a authenticator or a bunch of authenticators that allow you to actually prove your identity using a certificate. And what this means is that now you can actually connect to Cassandra without using a password. You obviously need some certificate infrastructure in your setup, but overall, that capability gives you the ability to connect to Cassandra without a certificate, without passwords, using certificates. And what we do is we actually authenticate you at network connection level. What it means is that if you do not possess the correct certificate that we recognize, your connection is going to be terminated at the network layer, which is different from terminating it once you are authenticated, and then terminating your connection is different than doing it at the network layer itself. So I have a list of authenticators here that you can use. So let's say you want to deploy mutual TLS on your cluster and you don't have passwords. You can directly use a mutual TLS authenticator in Cassandra. This is in 5.0. And if you have passwords, if you want to maintain compatibility or transition your users from password-based authentication to certificate-based authentication, you can use this other authenticator, which is the fallback authenticator. And then we also have an internode authenticator. And that's kind of important because at this point, I don't think Cassandra internode has a very strong authentication story associated with it. So those are the authenticators that you can use, and basically all the surface areas or the connections that you have would be authenticated using certificate-based authentication. I have a small demo that I would like to share with you all that demonstrates this.
Really want to do this, huh?
Yeah, I'm trying to be adventurous. All right. Okay. All right, it's working so far. All right. So what I have here is a Cassandra cluster. I am logged in as the regular Cassandra user, and if you do system auth roles, you'll see I have this default user called Cassandra. You can see that it has a salted hash, which basically is the password of that user. So I'm going to create a user, which is basically create a role, which is a password user. This user is using a password called password. And once this user is created, before I log in, let me show you something cool. So if you so there is a system view. I don't know how many of you know virtual tables in Cassandra, but Cassandra has a virtual table that shows you all of the client connections. And what we see here is right now there's one user that's logged in using password authentication and without SSL. So this is a user that is logged in using a username password and using plain text. So that's insecure, basically. But the current new user that I created can actually connect using SSL. So this user is using SSL and but still using a password, right? So all right, so this user was created and is connected using password. So let's see what does this show. So now you can see that this new user that I just created is connected using password-based authentication, but also is using TLS 1.2, which means they are actually connected over a secure channel, but they're still using a password. So we can go one step further and we can say, I want to create a MTLS user in the system. This is just a username. MTLS user is just a username. When I try to connect using this username, it says, I'm sorry, I cannot connect because I'm not authorized, right? So I am providing a certificate to the server, but obviously I have not configured the identity of this user on the server side. So I can add the identity. Now, what is this identity? This is the identity that is embedded inside the certificate of that user. So when I add the identity of this user into the certificate, before I log in, let me show you system auth roles table. This user that I created, MTLS user, it does not have a password like the other two users. And as a result, it won't accept a password as a secret. So if I go here again, and now I try to connect, I'm able to log in. So if I go back to my terminal here and ask it, so how's this other user connected, this new user that was just created? I'm connected over TLS 1.2 using mutual TLS. And I'll go back to the other prompt and I'll show you that this user does not have any username and password associated with their account. All they have is just the SQL RC file. And we can take a look at that file as well. And if we see this, it has two things of note. That the file that particular file basically tells SQL that connect using my private key and my user certificate, right? This is what's passed to the server, or rather it's used for the connection. There's no password or anything else in this file. The only other thing is it sets the SSL to true, so it's ensuring that it's using an encrypted connection. But basically, what this means is I can do the same things that I usually do on this terminal, and I just don't have a password associated with this account. So now, unless somebody possesses my certificate, they're not able to log into this account with any other credentials other than the certificate. So this is something that's coming to the sidecar as well. We already have worked on it, and we have MTLS in Cassandra 5.0 coming with 5.0 release as well. So that's pretty much it from me. Thank you, everybody.